Assalamualaikum warahmatullahi wabarakatuh and good morning. My name is Intan Sharfinaz binti Osman. My membership number is 181091229 and I'm student from RK23. So today, I'm going to present the project simulation entitled Analysis of Three-Phase Y Connected Generator. So, in my presentation, I've divided into 6 parts. By the first part, I'm going to explain about introduction, followed by objective, then methodology, and the first part I'm going to explain about calculation and results. Fifth part is discussion, and the last part is conclusion. Stay tuned. So now let's move to the first part, which is introduction. Most of the electrical energy used in the world is alternating current, where it uses three-phase system. The value of alternating current fluctuates between a maximum positive value and minimum negative value with a zero reference, which is named neutral or ground. This current is a sinusoidal wave. When only a single sine wave is generated, the electrical current is referred as single-phase current. Three-phase alternating current electrical energy is generated by three-phase generators and transmitted over three-phase circuit systems and wiring. We can see a three-phase circuit as three single-phase circuits consolidated into one circuit system with either 3 or 4 wires. Each one of the phases or waves generated can be separated using 2 wires only. Using this single wave, single-phase motors and other single-phase loads may be operated from a three-phase circuit. In industrial operation, or whenever it is available, three-phase circuits are preferable to use over single-phase circuits. There's only 2 standard connections are used in three-phase work to fit system used to connect single-phase loads, which are Y and delta connection. In the study, students will focus on three-phase Y connected generator, transmission loss and load with acceptance, power factor lagging and frequency as stated according to Electricity Supply Application Handbook Volume 3. Next part is objectives. In this project simulation, there are 3 objectives. But the first one is to analyze the three-phase Y connected generator in electrical system. Second is to evaluate the parameters of the connected Y generator in the context of transmission and load impedance, currents and voltage with acceptable voltage drop. And the last one is to study and evaluate the active power absorbed by the loads by using 2 wattmeter method and the conventional measuring method. Okay, so now I'm going to explain the methodology of project simulation. As you can see here, this is the flowchart of the methodology. So first, the circuit of Y-Y connection as shown here for three-phase system has been connected. The line-to-line voltage 275 kV has been input to the Y connected generator. Third, the value of transmission loss and load were input into the circuit after convert from L to XL by using equation XL equal to 2 pi FL. And the last one, all the parameters of the Y-Y connection in the context of transmission and impedance, currents, voltage and absorbed power were measured. And so now I'm going to explain for the first part, which is results and calculation. Okay, for calculation, the value of line-to-line voltage is 275 kV. The value of transmission loss ZS equal to 29 plus 12 J ohm. The value for transmission load ZL equal to 81 plus 9 J ohm. The Z total, which is ZL plus ZS, is equal to 110 plus 21 J ohm. In Y connection, line voltage is equal to set3 phase voltage, where to get the phase voltage, we have to divide the I line with set3. So from this value of line voltage divided by set3, we got this value, which is 158.77 kV. Okay. For phase voltage, the value of EAN equal to 158.77 kV with 0 degree. For EBN equal to 158.77 kV with 120 degree. And ECN is equal to 158.77 kV with negative 120 degree. Since the sequence is in positive, so the AN is the degree for AN is 0, degree for EBN is 120, and degree for ECN is negative 120. Okay, for Y connection, line current and line phase current is equal. So if we just calculate for line current, we simply got the phase current. So for IAA, which is equal to EAN over Z total, the value is 1.417 kiloampere with negative 10.8 degree. And for IBB, which is EBN over Z total, the value is 1.417 kiloampere with negative 130.8 degree. And for ICC, which is ECN over Z total, the value is 1.417 kiloampere with 109.2 degree. For phase voltage load, the EAN that we got is IAA times Z load, which is 1.417 kilo with degree negative 10.8 times by 81 plus 9J. And the value EAN that we got is 115.48 kilovolt with negative 4.5 degree. And for EBN, we multiply the IBB with Z load. So the value that we got is 115.48 kilovolt with negative 124.5 degree. For ECN, the how we get the ICN is we multiply the ICC with ZL. So the value that we get is 115.48 kilovolt with degree 115.5. For the voltage drop, the formula is voltage supply minus voltage load divided by voltage supply times 100. So the voltage supply that we calculate is 158.77 kilovolt minus by 115.48 kilovolt here, and we divide by 158.77 kilovolt and we times 100. So the value that we get is 27.3%. For active power absorbed, the value of power for PA, PB, and PC is equal. So if we just calculate for PA, we simply got P total, where we just have to times the value of PA by 3. Okay, so to get the PA, we just use the formula voltage AN times IAA with cos theta. So AN 48 kilovolt times with IAA, which is 1.417 kiloampere, times with cos theta, which is negative 4.5 plus 8.8. And the value that we got for PA is 162.65 megawatt. To get the P total, we just simply multiply the PA with 3. So the value that we got is 487.94 megawatt. Okay, reading, this is the reading for line voltage. Okay, as you can see here, the value of VAB is 283 kilovolt. Okay, from the calculated value is 275 kilovolt for voltage line, but from the measured value from PSIM, we got 283 kilovolt for every line voltage, EAB, EBC, and ECA. Next, for line current, the value that we calculate is 1.417 kiloampere, but from the measured value from PSIM, we got IAA is 1.418 kiloampere, for IBB is 1.409 kiloampere, and for ICC is 1.407 kiloampere, which is
the value for measured current, the value for measured line current has slightly different with the calculated value for line current, as you can see here. Okay, next is phase voltage for load. Phase voltage for load, the calculated value is 115.48 for all the phase voltage load, but from the simulation we got VAN equal to 115.56 kilovolt, and for VBN is equal to 115.19 kilovolt, and for ACN we got 115.17 kilovolt, which is also it has slightly different with the calculated value. Next is reading of 2 watt meter. Okay, to get the reading of 2 watt meter, we just take the value of P total. So the value of P total is from P1 plus P2, which is P1 is IAA times with VAB, which is the value is 228.9 megawatt, plus with P2, which is ICC times VBC, which the value that we got is 256.19 megawatt. And the total from P1 P2 we got 485.11 megawatt, which is the value for 2 watt meter for calculated and measure also have slightly different. And the last one is conventional measuring method. Okay, for conventional measuring method, also like 2 watt meter method, we just take the P total, where P total is total value from P1 plus P2 plus P3, where P1 we got P1 is IAA times VAN, P2 VBB IBB times VBN, and P3 ICC times VCN. So as you can see here, the value that we got from P1 is 162.87 megawatt, and for P2 is 161.18 megawatt, and P3 161.05 megawatt. So the total of P, which is equal to a value for conventional measuring method, is 485.11, but which is also slightly different from calculated value.
Fifth part of the presentation, which is discussion. For the discussion, in Y configuration, line current and phase current are same, but not for line voltage and phase voltage, where in Y connection, phase voltage is 0.577 times more than line voltage. Based on the data collected, the value between calculated and measured on PSIM value have slightly different for all the parameters in the context: currents, voltage, and power absorbed by loads, either using 2 watt meter method or conventional measuring method. For line voltage, the actual value is 275 kV, but from the simulation is 283 kV, where it has 8 kV difference. Next, since line current and line voltage are same, students just measured the value for line current, where the calculated value is 1.417 kA, and the measured value has a very slightly different, and mutual current is 0 since the current load in 3 phases are same. From this experiment, the measure value for 2 watt meter method and conventional metering method are same, but they are a little bit different, which is 2.86 megawatt. In the last part of presentation, which is conclusion. To sum up all, Y configuration is used to distribute power to everyday single-phase appliances found in home and office. Since the insulation is decided by phase voltage, and for Y connection is 0.577 times line voltage. For delta connection, phase voltage and line voltage are equal, since the insulation level is decided by phase voltage, and for Y connection, phase voltage is 0.577 times line voltage, and hence Insulation required in Y connection is nearly 57.7%, where it can be used for high voltage generation. Then the insulation that will be required in delta configuration for same line voltage, and hence cost for insulation will be reduced. Neutral point, the neutral wire can be drawn using the neutral wire can be any one phase can be used as single phase. In this experiment, the three-phase connected generator in the electrical system has been analyzed, and all the parameters of Y-Y connection in the context of transmission and load impedance, currents, voltage drop have been evaluated. Lastly, students are also able to evaluate the power absorbed by using 2 wattmeter method and a conventional measurement method. This experiment has been validated with simulation of Y-Y connection. That's all from me. Thank you.